Use 1 minus 2x to the power of 10 to find an approximation of 0.96 to the power of 10. Use 2 plus x over 2 to the power of 8 to estimate for the value of 2.05 to the power of 8. Given that the coefficient of x squared is 29 times the coefficient of x, work out the value of p.
Hey everyone, George here, and this is part 2 of binomial questions. Okay, so this is the medium level questions that we'll be expected to come across in this topic. Let's get on with it.
Okay, so looking at question 1, it tells us use your expansion of 1 minus 2x to the power of 10 up to including the term x cubed to find an approximation of 0.96 to the power of 10, stating clearly the substitution which you have used for x. Alright guys, so first thing we do is what we have always been doing so far. We're going to be expanding 1 minus 2x to the power of 10 up to the term x cubed.
Now we have already done this expansion in the previous video for easy level binomial questions. Check it out if you want to nail the basics.
So we can already say that 1 minus 2x to the 10 is 1 minus 20x plus 180x squared minus 960x cubed. Now essentially we want to create an equivalent approximation for 0.96 to the power of 10. How would we do that using the expansion of 1 minus 2x to the power of 10? We can both see that they're both to the power of 10. Essentially what that means is we're going to have to substitute 0.96 for 1 minus 2x. So what we would need to do is replace 1 minus 2x for 0.96, and doing that requires us to substitute a certain value of x, and for that value of x it will be necessary for it to be 0.02. And why is that? 1 minus 2x to the power of 10, when you substitute x into it, we get 1 minus 2 times 0.02 all to the power of 10. And then that simplifies to 0.96 to the power of 10. So now we know that our value of x has to be 0.02. Plugging that here, here, and here would give us 1 minus 20 times 0.02 plus 180 times 0.02 squared, take away 960 0.02 cubed. Now all we have to do is just simplify it. We get 1 take away 20 times 0.02, which is minus 0.4, plus 0.072 take away 0.00768. And if we were to calculate all of that together now, that would just give us 0.66432. Now let's actually compare that to when we calculate 0.96 to the 10 in our calculators. We get 0.664832636 approximately, which is quite close to our approximated estimated version. Okay, now, so going on to the second question, we are told, find the first 3 terms in ascending powers of x of the binomial expansion of 2 plus x over 2 to the power of 8, giving each term in its simplest form. So 2 plus x over 2 to the power of 8, we have got 2 to the power of 8 plus 8c1 times 2 to the 7 multiplied by x over 2, plus for our third term, 8c2, 2 to the power of 6 times x over 2 squared. Simplifying that further, 2 to the 8 is equal to 256, 8c1 is 8, times 2 to the 7, which is 128, times x over 2, plus 8c2, which is 28, times 2 to the 6, which is 64, times x over 2 squared, which is x squared over 4. And then simplifying that finally, we get 256 plus 512x plus 448x squared. And now for the more interesting part of the question, part B. Explain how you would use your expansion to give an estimate for the value of 2.05 to the power of 8. So now, similarly to what we did in our last question, in our expansion of 2 plus x over 2 to the 8, we need a certain value of x to make the number inside the brackets 2.05. So with some quick working out, we realize that 2 plus x over 2 becomes 2.05 when x is equal to 0.1. So with some quick working out, when x is 0.1, if we were to plug that in, we would get 2 plus 0.1 over 2 to the power of 8, which is the same as 2.05 to the power of 8. Therefore, we know definitely that 0.1 is the replacement for x that we need for this question. So substituting that into our expansion, we get 256 plus 512 times 0.1 plus 448 times 0.1 squared. Simplifying that further, expanding the brackets now, we get 256 plus 51.2 plus 4.48, which is equal to 311.68. Again, let's just give that a quick comparison to how we would do that in the calculator, and 2.05 to the power of 8 gives us 311.9111418, and so on. And as we can see, this is not too far away from our answer, our approximation by using the binomial expansion. And now for our third question. So this one's a little bit different, a little bit more interesting. Part A is a bit business as usual. They're asking us to find the first three terms in ascending powers of x of the binomial expansion of 5 plus px to the power of 30, where p is a non-zero constant. We're just going to expand this binomial expansion as normal. 5 plus px to the power of 30 is equal to 5 to the power of 30 plus 30c1 multiplied by 5 to the 29 times px plus 30c2 times 5 to the 28 times px all squared. We could go on. Again, they're just asking us to find the first three terms. Now to simplify this a little bit more, we have 5 to the power of 30 plus 30c1, which is 30 itself, times 5 to the 29 px, add 30c2, which gives us 435, multiplied by 5 to the 28, times p squared times x squared. Now notice that 5 to the power of 30, if we were to find a calculation of that, we would get some horrible number, 9.3132254746 times 10 to the power of 20. I think it's just much better to keep it as 5 to the power of 30. We don't want to deal with any ugly numbers at this point. And now for part B. Given that in the expansion the coefficient of x squared is 29 times the coefficient of x, work out the value of p. Remember, coefficient is whatever number is in front of x, or x squared, or x cubed, or whatever x term there is. Okay, so we can see the coefficient of x is 30 times 5 to the 29 times p. And the coefficient of x squared, which is 435 times 5 to the 28 times p squared, is 29 times the coefficient of x. Now in these kind of questions, they always expect you to turn this into an equation. And this is how we do it. Well, we know that the coefficient of x times 29 gives us the coefficient of x squared. As an equation, that becomes 30 times 5 to the 29 times p, which is the coefficient of x. We multiply it by 29, and that would give us the coefficient of x squared, which is 435 times 5 to the 28 times p squared. Now this requires us some GCSE level knowledge. We just need to rearrange this equation to make this a bit nicer for us. So already I can see I can cancel out the p's. So I can divide by p on both sides. On the left hand side that cancels out just p, and on the right hand side that cancels out the p squared to just p. What else can I do? I can divide everything by 5 to the power of 28. So on the right hand side of the equation, 5 to the power of 28 over 5 to the 28, they cancel out completely and utterly. On the left hand side, what we see is that 5 to the 29 over 5 to the 28, they cancel out such that 5 to the 29 is now reduced to just 5. This is just basic power laws, which we have gone through GCSE. If you're having trouble with that, I suggest you stop this video and revise that immediately. You can't be doing binomial expansion and not knowing your power laws. Okay, so when all is said and done, just to write everything a bit more cleanly, we have 29 times 30 times 5 now being equal to 435p, and to equate the left hand side we get 4350, which is equal to 435p, and just by looking at it we can already tell that p has to be equal to 10, and that's it. We have found the value of p. So this question included the binomial expansion formula and some knowledge of power laws. That's pretty much it.
And that's it. If you've seen the previous easy level video, we have used the same foundational rules that we have already established to tackle these questions. So yeah, that's all for now. If you have found any of the questions helpful, give us a like, give us a comment as well. If you haven't found it helpful, also give us a comment. I want you to let me know what you think. And of course, contact me if you require any tuition. I have my details down below. Okay, George out.